Welcome to the Math 1, Unit 8, Lesson 3 summary video. Blocks are multiplying everywhere. This lesson is a Solidify Understanding task which takes concepts developed previously and helps you formalize those ideas. The purpose of this lesson is to extend the work of factoring by making connections between the area model, the factored form, and the standard form ax squared plus bx plus c with an a value other than 1 of a quadratic. When we see these functions written in the trinomial form of ax squared plus bx plus c, we refer to that as standard form. And this is referred to as factored form because these are the factors that we're using to multiply together to get to the standard form. In today's lesson, we will look more closely at how we can get from the standard form into the factored form, keeping in mind that these are equivalent expressions and they both represent the same area model. Notice that we are using the letters A, B, and C to refer to these coefficients in our standard form. In the first example, we're given a rectangular quilt and we are asked to make that quilt twice as big. So we want it to be a multiple of the original quilt. And we're going to again start with that x by x block and extend one side out by 3 inches, the other side out by 1 inch, and they want us to make that twice as big. So the top dimension is x plus 3, so we're going to add another x plus 3 to the top. The side dimension is x plus 1, so we're going to duplicate that as well. We've got the x, and now we've got the plus 1, and we're going to fill that in. So you notice that all we did was take the original rectangle and we duplicated that. And so we added another x plus 3 to the top, and the dimension on the left, that stayed the same. So it's still x plus 1 by x plus 3. And so now if we look at the top, what we have are 2 x's plus 6. So altogether, this is 2x plus 6, and the left side is still x plus 1. If we look at the original dimensions, the x plus 3 times x plus 1, that's written here. But now the new quilt, I have 2 of the x plus 3's. So I doubled 2 times x plus 3 times x plus 1. If we distribute that 2x, or the 2 to the x and the 3, we get 2x plus 6 times x plus 1 and then if we distribute the 2x to my x and the 2x to my 1, I get 2x times x is 2x squared. 2x times 1 is 2x. And then distribute my 6 to each of the terms. 6 times x is 6x, and 6 times 1 is 6. I'm going to simplify by combining like terms, and I get 2x squared plus 8x plus 6. So I have 2x squares plus 1, 2, 3, 4, 5, 6, 7, 8 x's plus 6 1's. And so you can see in standard form what this model looks like, and in factored form what it looks like. Notice that if we look at the standard form for this original rectangle, we have x squared plus 4x plus 3. And if we look at the entire new rectangle in standard form, we came up with this trinomial, the 2x squared plus 8x plus 6. And if you look from each of the terms in the final rectangle, and you compare each of those terms to those of the original rectangle, you should see a pattern here. You should see that if we divide each of these terms by 2, we end up with the trinomial of the original rectangle. In other words, if we factor out a 2 from each of these terms, we end up with 2 of these trinomials, because this expression here represents one of these, but we have 2 of those. And we know that the binomial factors that make up this trinomial are the x plus 3 times the x plus 1. And we have 2 of those x plus 3s times x plus 1s. So essentially what we did here is we looked for you can look for the greatest common factor of each of the terms in the trinomial, and if they have a greater common factor than 1, you can factor that out, and that will be a third factor. So you'll have that common factor, the greatest common factor of all of the terms, times the 2 binomial factors, and that will give you the entire combined area. And we're going to explore that a little bit more. So if we look at this first example here on the left, and we are looking for the greatest common factor of each of these 2 terms. Well, I know that I can factor out a 6. I can divide each of these by 6. And I know that they each have an x, so I can divide each of these by x. I can factor out a 6x from each of the terms. So if I factor out the 6 and I factor out the x, what I'm left with, 6x squared divided by 6x is x, and 12x divided by 6x is 2. So what that tells me is, if I start with my x by x, on one side I'm going to have a length of x, and on the other side I'm going to have a length of x plus 2. So I'm going to add 2 more here. But I don't just have one of these, x by x but x plus 2 rectangles. I have 6 of them. So I'm going to duplicate this or multiply this by 6. I'm going to have 6 of these. And so here you can see now that I've put 6 groups of the x plus 2, and we've got 1, 2, 3, 4, 5, 6 x squares, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's. So we have 6 groups of x by x plus 2. In looking for the greatest common factor in this second example, we see that we can divide each of these terms by 2. Their greatest common factor is 2. And so when we factor out that 2, what we're left with is 2x squared divided by 2 leaves me with x squared plus 2x plus, not plus, minus 3. So we have negative 6 divided by 2 gives me negative 3. Now I'm looking for my binomial factors. In other words, the factors that make up x squared plus 2x minus 3. Well, I know that I have to have an x times an x to give me that x squared, and I know that I've got to have a positive times a negative in order to give me a negative 3. And I know that in order to, the only factors that I can multiply together are 1 and 3. So I can do negative 1 times 3 to give me negative 3, or I can multiply 1 times negative 3 to give me negative 3. I'm looking for the factors that would also add up to positive 2. So I know that if I add negative 1 plus 3, that equals positive 2. 1 plus negative 3 would give me a negative 2. So it can't be this pair, it has to be this pair. So it's going to be x minus 1 and x plus 3. And if we look at that in terms of our model, we have 1x squared, we have 2 x's, and we're getting that by adding 3 to one side and taking 1 away from the other side. And that's going to leave me with these 3 negative units. So I've got x squared plus 2x. Remember, these are a 0 pair and they cancel out, so I've got these 2 x's left, minus 3. But remember, we factored out that greatest common factor of 2, and this is saying I have 2 of these groups. And so I have to add another group of these. And it looks like this. So now, when we cancel out this 0 pair again, now I've got 2x squared plus 4x, 1, 2, 3, 4, minus 6, 3 negatives here and 3 negatives here is 6 negatives altogether. In the next example, we're given the complete area and one side length, and we are asked to find the other side length. And so it tells us that we have one side length that is x plus 3. So I have that one side length. And so I've got to figure out what this other side length is so that I have a whole combined area of 2x squared plus 7x plus 3. Well, I know that I only have one x squared right now, and I need another x squared. Also, before I move on, let me point out what's different about this one, other than the fact that we're given one side length, is that we can't, when we look at this in standard form, this trinomial, there's no common factor other than 1 with all 3 terms. So this has a coefficient, this first term has a coefficient, but we can't factor it out because we can't divide 7 by 2 evenly or 3 by 2 evenly. So their only common factor is 1. So we're going to use the area model to try to help us figure out what the other factor is that we would be multiplying x plus 3 by to get this trinomial. So I know that I have 1x squared, and I need to end up with 2x squares. I know this side length is x plus 3, so it's not changing. So I'm going to have to add another x squared tile, which is x by x, so that I have 2x squares. I know that I need to fill in these with x's because I'm given this side length of 1, and when I put this x in, I'm given this side length of 1 and this side length of x, so 1 times x gives me x, so I know that this has to be filled in with an x tile. Well, now I've got 2 x squares and 6 x's, but I need 7 x's altogether. So if I take another x tile and add it to this side, I'm adding 1. Now I have a side length of 1 and a side length of 1 here, which means I can fill those in with single unit blocks. And so now I have 1, 2, 3, 4, 5, 6, 7 x's, which is what I need, and I have 3 1's, which is what I need. So this side length is x plus 1. X plus x is 2x plus my 1. So the side lengths are x plus 3 times 2x plus 1. And I can distribute to check and make sure I have the right answer. And I get x times 2x is 2x squared. X times 1 is x. Distribute my 3 times 2x is 6x. My 3 times my 1 is 3. Simplify by combining like terms. 2x squared plus 7x plus 3. And so if I were going to be looking at this outside of an area model, I know that I need to multiply these first 2 terms, my x terms, to end up with 2x squared. If I have an x already, I'm asking myself, what can I multiply to x to end up with 2x squared? And I know that has to be 2x. Additionally, I know that I have to have a positive 3. So these constants have to multiply together to give me a positive 3. That could be a positive 1 and a negative 1. I'm sorry, a positive 1 and a positive 3, or a negative 1 and a negative 3. Both of those would give me positive 3 as a product. However, I also know that I have all positive x's. And if I know that this is already a positive 2x, and I multiply that, I'm going to end up distributing this 2x with the 3. That's going to give me 6x. Well, if this 3 were negative, that would give me negative 6x's. And if this 1 were negative, when I multiply these two together, that would give me a negative x. And when I added all of those together, that would give me negative 7x's. So these have to be positive 1 and positive 3. In this last example, I am going from standard form and I'm trying to find the factored form. I know that when I multiply the first 2 terms of my binomial factors, they have to have a product of 3x squared. So I'm asking myself, well, what can I multiply together to give me 3x squared? I know that I can multiply 3x times x to give me 3x squared. I also know that I've got to multiply these constants together to give me negative 10. So I've got 4 options. I can multiply, I know one has to be positive and one has to be negative, and the factors of 10 are 1 and 10 and 2 and 5. So I could multiply negative 1 times 10, or 1 times negative 10, or negative 2 times 5, or 2 times negative 5. And just because I select the correct pair, when I'm selecting the correct pair, I also need to keep in mind where I place them. For instance, if I place the negative 1 here and the positive 10 here, yes, when I multiply these two together, I get the 3x squared. And yes, when I multiply my constants, or the second terms together, I get my negative 10. But now I need to think about this middle term, my b term. So I get that by multiplying the outside terms together and the inside terms together. this is the 3x times 10 gives me that 30x, and the negative 1 times x gives me negative x, and then I combine those like terms and I get 29x. So I know that this is not the right placement or combination because I don't end up with one positive x. Well, what if I switch them around, and instead of putting the negative 1 here and the positive 10 here, I put the positive 10 here and the negative 1 here. Well, now I end up with 3x negative 3x and positive 10x. And still, when I simplify those or combine them, I end up with 7x. So these don't work. This pair right here will not work. And I'm still going to end up with these same factors. The signs may be different, but I'll still get the same factors even if I switch these around. So I know that these are too far away from each other, the 1 and the 10. To be able to work. So if we tried that positive 1 and the negative 10, I would have negative 30x and positive x, and now I have the negative 29x. So you'll see that we'll still end up with 29x and 7x. It's just that the signs are going to be different. And so the 1 and the 10 won't work. So I know that it's the 2 and the 5. What I'm not sure about is which one needs to be positive and which one needs to be negative, and where should I place them. And so if I place my negative 2 here and my positive 5 here, again, these two, when I multiply them together, give me my first term. When I multiply the last two together, it gives me my last term. When I multiply the outside terms together, I get 3x times 5, which is 15x, and negative 2 times x, which is negative 2x, and that's going to give me 13x, which doesn't give me my positive x value. So what if I switch these around, keep the negative 2 and the 5, but put them in a different order? So if I put my positive 5 here and my negative 2 here, now I've got 3x times negative 2, which is negative 6x, and 5 times x, which is positive 5x, positive 5x, which gives me a sum of negative x, and I need it to be positive x. So that's not going to work. So we know that it's not this one. So now we have plus 2 and minus 5. Let's try this. 3x times negative 5 is negative 15x plus 2x. That's not going to work. So we can switch those around. And say 3x minus 5 and x plus 2. And now I've got 3x times 2, which is 6x, and negative 5 times x, which is negative 5x, and that sum, or difference here, is x. And so that gives me the middle term that I need. So the factored form of this expression is 3x minus 5 times x plus 2. And using the algebra tiles, I know that I have to have 3 x squares. And I also have to have positive x's on one side and negative x's on the other side in order to get these 10 negative 1 units. So I can add one of each and see what happens. So if I start with my x, and x plus x plus x, if I add 1 to this side and take 1 away from this side, I know it's going to look like this. So I'm going to try to add another one. To each side, and it looks like this. Now, I know that if I add 3 more positive x's, so right now I've got 6 positive x's and 2 negative x's. So these 4 right here would create 2 zero pairs, and I'd be left with 4 positive x's. So that tells me that I need to add another negative x to offset these, because I need to only end up with 1 extra positive x. So now I've got 3 negative x's and 6 positives. Well, that's still too many because I only need 1 extra positive x. Now I've got 4 negative x's and 6 positive x's. So I'm going to add another negative x. Now I've got 5 negative x's and 6 positive x's. That leaves me, with my 0 pairs canceling out, it leaves me with 1 extra positive x, and I have my 10 negative 1's. So this side is x plus x plus x, or 3x plus 1, 2, 3, 4, 5, negative 5, or we can say 3x minus 5. So this side is written as 3x minus 5, and this side was x plus 2. And you can see that that matches up with what we found earlier. So a couple final notes just to recap. When I'm going from standard form to factored form, I first want to look and see, do I have a common factor other than 1 in each of my terms? If I do, I need to factor that out first. Then I'm looking for the first 2 terms that multiply together to give me the first term in my trinomial, and I'm doing that with all 3 cases. Then I'm looking for the factors that give me the product of the last term in my trinomial. So what are the 2 numbers that multiply together to give me this last term? 3 times negative 1 gives me negative 3. 1 times 3 gives me 3. Negative 5 times 2 gives me negative 10. If my first term in my trinomial has a coefficient of 1, then I am looking for these 2 numbers to add up to give me this middle term, the coefficient of the middle term. So 3 plus negative 1 gives me 2. If they don't, and keep in mind, if we don't factor out the greatest common factor, it's not considered to be in factored form. So if I had this 2 still in here, 2x plus 6 times x minus 1, that would not be considered to be in factored form. We have to factor out the greatest common factor. When we're looking at these trinomials that we can't factor a greatest common factor out, and so we have a coefficient for our first term, we're multiplying, we're figuring out what 2 numbers can I multiply together to give me this first term. Same thing here. What can I multiply together to give me my last term? Same thing here. And now, if you notice, if we multiply the term with the coefficient, the first term, the x term with the coefficient, times the constant in the other factor, so if we multiply just the coefficient, the 2 times the 3, and then add this number, plus 1, I get 6 plus 1, which is 7, and that gives me the coefficient for my middle term. Same thing here. If I multiply the 3 times the 2, and then I subtract 5, or I add a negative 5, I get 6 minus 5, which gives me positive 1, and you can see that's my coefficient here. And it's just going to take practice doing these over and over again to get used to it. And until then, you can continue using the area models to help you.